Hi friends, welcome back to a new session. In this session, we'll discuss production of rotating magnetic field in a induction machine. Okay, let me write here production of rotating magnetic field, or I can say RMF. Okay, production of rotating magnetic field, production of rotating magnetic field. Next we'll discuss double field revolving theory also. Double field revolving theory. Yeah. See, first of all, let me discuss here. Let me keep heading here. Production of a rotating magnetic field. That is what RMF in a three-phase induction motor. So heading is production of rotating magnetic field in a three-phase induction motor. See, what are the conditions for producing rotating magnetic field in a three-phase induction motor? It's very simple. See, let me write these two conditions. There are two conditions we have to follow for producing rotating magnetic field. Number one, here three-phase currents should be time displaced by 120 degrees electrical. And the second condition, that means what, like this. Suppose if you take a ABC three-phase system, example, if you take A phase current, B phase, C phase. If you take reference IA and IB are time displaced by 120 electrical, IB and IC are time displaced by 120 electrical, and IC and IA are time displaced by 120 electrical. That means three-phase currents are time displaced by 120 electrical. So that means, let me write here, example I have taken IA reference. So IA is equals, let me take Im cos omega t, and IB, let me take Im cos of omega t minus 120. If you have see observe clearly, your IB lags IA by an angle of 120 electrical. That's why I'm writing the IA means cos omega t reference for us. So IB lags IA by an angle of 120 electrical. That's why I wrote here Im cos of omega t minus 120. Now what about IC? IC is equals to Im cos of omega t minus, if you take IA vector, when compared to the IA vector, it is lagging by 240. That means minus 240 I can write, or I can write plus 120 also. It is lagging by 240 or leading by 120. Both are correct only. So let me take IC is equals to Im cos of omega t plus 120. These are the three-phase currents time displaced by 120 electrical. Now second one. What is one more condition for producing rotating magnetic field is, in a three-phase induction motor, we are having A phase, B phase, C phase, three phases are there, okay? In A phase, we are placing some windings, okay? And you have to maintain a physical displacement angle of 120 electrical, so then only I can place windings in B phase. That means there should be physical displacement of 120 electrical between A phase windings and B phase windings. B phase windings and C phase windings. Similarly, C phase windings and A phase windings. So example like this. Here I can write third condition. So three-phase windings should be are physically displaced by or space displaced by whatever. Physically displaced by 120 degrees electrical. That is, if you take example A phase, in A phase I just placed windings N phase cos theta turns I place in A phase. In B phase, you have to maintain 120 electrical when compared to the A phase windings, A phase number of turns. So N phase cos of theta minus 120. In C phase, let me take N phase cos of theta plus 120. These are the number of turns I have taken in A phase, B phase, C phase, and these are the currents I have taken in A phase, B phase, C phase. Why I have taken here current and number of turns only? Because our topic is production of rotating magnetic field. That means I have to show magnetic field is produced and it is rotating. See, magnetic field nothing but flux only. Flux is because of what I can say MMF. Because you know formula, flux is equal to the formula. Flux is equal to MMF by reluctance. And you know what is the formula for MMF? Number of turns into current by reluctance. That means MMF is equal to number of turns into current. If I want to show that flux is produced, magnetic field is produced, it is rotating, indirectly, if you take MMF is produced, MMF is rotating, so indirectly flux is also rotating, magnetic field is also rotating. That means let me discuss about MMF point of view. MMF means what I want, number of turns I need, current I need. That's why I take a number of turns here and I have taken current here. Okay. Now let us discuss about MMFs now. MMFs. So now please let me see MMFs here. What is that MMF due to A phase? MMF due to A phase. So in A, now what is the formula for MMF? I told you already. MMF is equals to, let me write once again here. MMF equals number of turns into current. If you want MMF due to A phase, in A phase how many number of turns are there? N phase cos theta. N phase cos theta into what is the current in A phase? Im cos omega t. Im cos omega t. Im cos omega t. I can write N phase into Im can be written as a maximum value of your MMF. FM I can write. FM means what? Maximum value of your MMF. FM cos theta cos omega t. This is what? Formula for FA equals to FM cos theta cos omega t. Okay, before explaining MMF to B phase, so let me tell you some points here. Some people may get doubts of why I had taken IA, IB, IC only cos function, not sin function. It's very simple. You can take sin or cos, anything you can take, nothing wrong. But if I take cos function, it is very easy for us to simplify. Okay, that's why I taken cos function. Cos or sin, nothing but sin only. Okay, therefore you can take cos. I mean, Im cos omega t. Im cos of omega t minus 120. Im cos of cos of omega t plus 120. Like that I can take. So now I got FA. Now tell me what about FB? MMF due to B phase. What are the number of turns in B phase? N phase cos of theta minus 120. N phase cos of theta minus 120. What is the current in B phase? Im cos of omega t minus 120. Let me take here Im cos of omega t minus 120. So I told you already N phase into Im can be written as what? Fm. So Fm cos of theta minus 120 into cos of omega t minus 120. This is what I can say FB value, MMF due to B phase. Similarly, tell me what would MMF due to C phase. Number of turns in C phase, N phase cos of theta plus 120. What about current in C phase? Im cos of omega t plus 120. So once again I am writing N phase into Im can be written as what? Fm. Fm cos of theta plus 120 into cos of omega t plus 120. This is what FC equals to Fm cos of theta plus 120 into cos of omega t plus 120. And Fr, resultant MMF equals to FA plus FB plus FC. FA plus FB plus FC. Now let me write directly here one equation, but I'll tell you how this equation came by using double field revolving teeth. So if you add FA plus FB plus FC, you'll get here 3 by 2 Fm cos of theta minus omega t. This is what resultant MMF wave is equals to 3 by 2 Fm cos of theta minus omega t. So let me have some observations or conclusions from this waveform, from this equation. So what is the amplitude? What is the amplitude from this resultant MMF waveform? 3 by 2 Fm. Yes or no? Let me say 3 by 2 Fm or I can say 1.5 FM. Next, second observation. If you observe clearly here, it's a FR, resultant MMF is a function of theta comma omega t, means what? This FR is varying with theta. So I told you already, so theta means what here? In A phase, I place N phase cos returns. And after 120, I just place N phase cos of theta minus 120. That means what? I can write here theta means space angle. Space angle, space angle, space angle. That means FR, resultant MMF is varying with space, comma time. So varying with space and time. If FR is varying with space and time, what is the meaning for that? That means it is rotating. It is rotating. So FR is a function of theta omega t, means what? I can write here FR varies. FR is a function of theta omega t, means FR varies with theta comma omega t. That is FR is rotating. FR is rotating. FR is rotating. I'll tell you with what speed this FR is rotating. That I'll tell you. Before that, FR varies with theta omega t. That is resultant MMF is rotating. I already told you flux is because of MMF only. If MMF is rotating, I can say that flux is rotating. Nothing but magnetic field is rotating. Therefore, let me write here. Therefore, that is rotating magnetic field. Rotating magnetic field is rotating magnetic field is produced. You may get one more doubt. With what speed your rotating magnetic field is rotating? Okay. So let me write here speed of RMF, rotating magnetic field, is equal to this. You have to fill up. Okay. So first I'll tell you this. Okay, I'll tell you. Let me draw one traveling MMF waveform. Okay, and let me find out what is the speed of your RMF also. Okay, before that, please note down up to this. Make it fast. Right. Yeah, please try to see here. You got FR equals to 3 by 2 FM cos of theta minus omega t. It's a very important equation. So tell me, let me draw one traveling MMF waveform. Traveling MMF waveform. It's nothing but let me take in y-axis FR, x-axis I'll take a theta. Okay. Please guys, FR equals to 3 by 2 FM cos of theta minus omega t. Okay. So I'm just drawing FR versus theta. Suppose if a theta equal to, if theta, I'm just varying, I'm drawing FR versus theta. Suppose if omega t equal to, let me take 0 degrees. That means 3 by 2 fm cos theta. It becomes cos function. So let me draw that cos function here. Okay, this is the shape. I can say whenever omega t equal to 0 degrees, at that time this is the shape of your FR. Tell me what is the amplitude for this waveform. What is the amplitude? I have given here 3 by 2 FM. 3 by 2 FM. 3 by 2 FM. And please tell me if omega t equal to 45 degrees. At that time your waveform will be like this. 45 degrees means you will be somewhere here. It will start like this. This is the waveform of resultant MMF if omega t equal to 45 degrees. And let me draw FR waveform if omega t equal to 90 degrees. Cos of theta minus 90, it becomes sine function. So this is what shape of FR when omega t equals to 90 degrees. So observe clearly why I called it as traveling MMF waveform means, yes, if you see when omega t equal to 0 degrees, it is here, and omega t 45 degrees, it is here, omega t 90 degrees, it is here. That means FR is varying with the time. Obviously it is varying with the space also, varying with the time, varying with the space. That means what? That's the reason why I wrote here, that is rotating magnetic field is produced if magnetic field or flux or MMF, if it is varying with the space and time, I can say that it is moving, it is rotating. That's the reason I can call here rotating magnetic field is produced. So this can be clearly understood by seeing your traveling MMF waveform. Now my question is, with what speed your MMF, resultant MMF, or I can say rotating magnetic field is rotating. So speed of rotating magnetic field is equals to, because I told you already, magnetic field is nothing but flux. Flux is because of MMF. If resultant MMF is there, that means resultant flux is there. If MMF is varying with the time and space, so magnetic field also varying with the time and space. So speed of that rotating magnetic field equals to, generally formula, generally we'll write velocity equals distance by time. Like that here, if you want speed of RMF equals to displacement by time. Here displacement I can take here omega t by time t. So this becomes omega E. Omega E is nothing but angular frequency. But I want speed in terms of RPM. For that, relation omega E, angular frequency is equals to P by 2, number of poles by 2 into omega M. Omega M means what? Angular velocity. This relation you have to remember. It's very important. Omega E equals to P by 2 into omega M. Angular frequency equals to P by 2 into angular velocity. So what is the formula for angular frequency? 2 pi f into equal to P by 2 into, what is the formula for angular velocity? 2 pi n by 60. Let me cancel 2 pi. From this tell me n is equals to, you'll get 120 into f by p. Here only frequency f is there. Suppose if some other frequency is here, I may not call that as synchronous speed. But since frequency is f here, I can call this speed is nothing but synchronous speed only. Therefore, here one important conclusion. So resultant rotating magnetic field is produced and it is rotating like this. What is the speed of magnetic field means how much in terms of RPM I'm asking, in terms of RPM I'm asking, ns. So many people will be having some confusion. I wrote here speed of RMF. This is very important, speed of RMF. So because some people will think, sir, you told now n is less than ns. There n means speed of induction motor or speed of rotor. Here ns means what? Speed of rotating magnetic field. Please don't confuse speed of rotating magnetic field with speed of motor or speed of rotor. Speed of motor or rotor is n, obviously, which is less than ns. In case of induction generator, n is greater than ns. At n equal to ns, I don't have any operation. That's for sure. But here, speed of RMF is ns. I'm not saying speed of rotor. Speed of rotating magnetic field is ns. This is very, very important. So this is very, very important. This point is very, very important. Okay. Speed of RMF is ns. Okay. So this is what I can say, your production of rotating magnetic field in three-phase induction motor. So please note down this traveling MMF waveform. Then I'll go for double field revolving theory. By using that, I'll show you how we got this equation. 3/2 Fm cos of theta minus omega. I wrote here directly. How we'll get this equation, that I'll tell you. Okay. First note on this. First note on this. Yeah, actually it's rotating. Rotating. Next topic. Next, in this only, let me continue. After completion of production of RMF, let me go for double field revolving theory, DFRT. Double field revolving theory. Double field revolving theory. Okay. See what double field revolving theory will say. Very simple. According to double field revolving theory, each individual MMF wave, example if you take FA, MMF due to A phase if you take, each individual MMF wave will be having two components, one in forward direction, one in backward direction. Okay, let me write here. According to double field revolving theory, each individual MMF waveform, each individual MMF wave is having two components. One in forward direction, comma, another in backward direction, So example, let me take FA. So FA here I wrote how much here? Fm cos theta cos omega t. So let me take this FA equals to Fm cos theta cos omega t. So according to double field revolving theory, this individual MMF waveform, whatever FA is there, can be, it will be having two components, one in forward, one in backward. So this equation can be written like this: Fm by 2 cos of theta minus omega t plus Fm by 2 cos of theta plus omega t. So this FA wave equation can be written like this. So here this portion Fm by 2 cos of theta minus omega t can be called as FA plus, and this portion can be called as FA minus. FA minus. FA plus means what? It's a forwardly rotating MMF wave, due to A phase with what speed? Tell me, I already told you what is the speed of your RMF ns. So this FA plus also is related with the speed ns. And what about FA minus? FA minus nothing but backwardly rotating MMF wave due to B phase, it's due to A phase only, due to A phase with the what speed? With ns. Is it clear? So let me indicate diagrammatically like this. So let me take reference here. See guys, I am taking in forward components, I'll take a FA plus reference. That means what? FA plus I'll take here. And in backward components, similarly FA plus FA minus I got. You'll be getting FB plus FB minus FC plus FC minus you'll get. So for forward components, FA plus reference. For backward components, FA minus reference. So let me indicate here FA minus. I told you FA plus is nothing but a forwardly rotating MMF wave. Forwardly means, let me take like this. So with what speed is rotating? Ns. See, it is not compulsory that you have to assume like this only. What I am just going to say, I will discuss in my discussion. I'll take a forward means I'll take anti-clockwise. Backward means I'll take clockwise. You may take reverse, also nothing wrong. Anyone you have to follow. Forward means I'm just taking like this, means anti-clockwise direction. Backward means I'm just taking like this, clockwise direction. This assumption is not compulsory. In my discussion, I will take forward direction means I will take anti-clockwise direction. Backward direction means I will take clockwise. It's all assumption only. You can take reverse also, nothing wrong. Okay. So it's a forward rotating MMF wave due to A phase with ns speed. So backwardly rotating MMF due to A phase with ns. Okay. Now similarly, whatever we just drawn FA into two components, I will write FB, FC also into two components. We'll see. So tell me, what about FB equation? FB I'm asking. FB. I wrote FA means FM cos theta cos omega t, like this. I have taken this one. So FB means, please take this one. FB is equals to FM cos of theta minus 120 cos of omega t minus 120. So you'll get here FB is equals to, I can write this equation like this, Fm by 2 cos of theta minus omega t plus Fm by 2 cos of theta plus omega t minus 240 will get. Minus 240 will get. Okay. So this can be taken as FB plus rotating with ns speed. This can be taken as FB minus rotating with ns speed. Let me indicate diagrammatically like this. This is reference. As I told you, for forward components, FA is reference for us. FA plus is here, nothing but reference here. So almost FB plus also, if it is theta minus omega t, it is also theta minus omega t. They are in phase. They are in phase. So let me indicate FB plus in phase with reference FB plus. And what about FB minus? FA minus here theta minus theta plus omega t. FB minus means theta plus omega t minus 240. So FA minus is nothing but is in phase with the reference. So that means when compared with your reference, it is lagging by how much angle? 240 degrees, 240 electrical, 240 degrees. Okay, so this is what I can say, FB minus, FB minus. Similarly, let me go for FC plus, FC components also. I'll divide into FC plus, FC minus. Then I'll get resultant one. Okay. So please, this one I'm writing FC. I'm writing here FM cos of theta plus 120. I'll write here. Please wait. So FC is equals to, if you want you can see this, whatever I just said here, that one I'm just writing here. FC is equals to FM cos of theta plus 120 cos of omega t plus 120. So this can be written like this, FM by 2 cos of theta minus omega t plus FM by 2 cos of theta plus omega t minus 120. Okay, I can write like this. Now, similarly as usual, once again, this portion can be called as, FC plus forwardly rotating MMF due to C phase with what speed? Ns. This is nothing but backwardly rotating MMF due to C phase with what speed? Once again, Ns. Okay. Now let me show diagrammatically like this. This is what reference plus FB plus means theta minus omega t. FA plus means theta minus omega t. Here FC plus also theta minus omega t. That means what? Your FC plus will be in phase with the FB plus, in phase with the FA plus. That means it will be here. FC plus is like this. So it's a forwardly rotating MMF. Means what? Forward means what I taken? Anti-clockwise direction. What about FC minus? FC minus theta plus omega t minus 120. Theta plus omega t means FA minus, or nothing but reference. Okay, when compared to reference, it is lagging by how much angle? 120. Therefore, this is what I can say, FC minus backward component. So it is rotating in a clockwise direction like this. FC minus with what speed? Ns. What speed? What? Ns. So this 3 by 2 FM cos of theta minus omega t, I am just going to get. How we are getting that, I'll show you. Just let me erase this. Similarly, please show here also FB plus forwardly rotating MMF due to B phase means in anti-clockwise direction like this, and FB minus means backwardly rotating MMF due to B phase, that means clockwise direction with what speed? Ns. Okay. So let's observe clearly now. Your backward components FA minus, FB minus, FC minus. Please show diagrammatically also. FA minus is here. Okay, FB minus is here. FC minus is here. That means your backward components will be like this. FA minus this portion. After 120 FC minus will come. Here FB minus will come. FB minus will come. See, these three components, backward components are displaced by 120 electrical. You know already, if three vectors are displaced by 120 electrical, what are their what about their vector sum becomes a 0. So I can write here FA minus plus FB minus plus FC minus is equals to, I can say, FR minus. This is what I can say, vector sum. If three vectors are displaced by 120 electrical, their vector sum becomes 0. Therefore, FR minus is equals to 0. That is what? Resultant. That is resultant backward MMF wave disappears. disappears. Now let us see what about forward components. Okay, FA minus, okay, sorry, FA plus, FB plus, FC plus. They are in phase. This is what FA plus, FB plus, FC plus. They are in phase vectors. Therefore, FR plus is equals to FA plus FA, FB plus FC plus. This is what I can say arithmetic sum, because they are in phase vectors. Now please see, FA plus means Fm by 2, FB plus means Fm by 2, FC plus means Fm by 2. What is the total value? 3 Fm by 2, or I can say 3 by 2 Fm cos of theta minus omega t, Fr plus. So please here observe clearly. So previously also we got this equation. After having FA, FB, FC, I simply wrote Fr equals to 3 by 2 Fm cos of theta minus omega t. This I am proving by using double field revolving theory. What double field revolving theory will say means, each individual MMF wave will be having two components, one in forward direction, one in backward direction. After that, I just showed here in this discussion. In this case, I had taken in this case, so I had taken IA value, Im cos omega t, IB, Im cos of omega t minus 120, IC, Im cos of omega t plus 120. I had taken ABC phase sequence. For this ABC phase sequence, we got this resultant MMF wave is rotating in a forward direction, because this FR minus means resultant backward, it is disappears. So only I can say that resultant forward MMF wave exists. That means, see, what I told, forward means ultimately your motor is rotating in a forward direction. In this case, that is, let me write here, that is, motor is rotating in a forward direction. Same, whatever we had taken previously, 3 by 2 Fm cos of theta minus omega t, same only we are getting, but I am just clearly showing here how your resultant backward MMF disappears, how it is cancelling with each other, how Fr minus is becoming 0, only why Fr plus is there. This can be explained by using double field revolving theory. There I just shown Fr minus equals 0, only Fr plus is there. That means motor is rotating in a forward direction. Okay, please note. So yes, let me have some conclusion here. If you see currents point of view, I had taken here in this discussion, I had taken IA here, IB, IC, I had taken like this. What is the phase sequence? ABC is the phase sequence, right? ABC is the phase sequence I had taken here. That means what? I had taken IA equals to Im cos omega t, reference. This is what reference for us. And IB is equals to Im cos of omega t minus 120 had taken. IC had taken Im cos of omega t minus 240, or I can say plus 120 had taken. This currents point of view. And windings point of view, if you observe clearly, in A phase we had taken number of turns, N phase cos theta turns I just placed. In B phase, physically I just maintained 120 electrical between B phase windings and A phase windings, cos of theta minus 120. And in C phase, N phase cos of theta minus 240, or I can say plus 120 you can take. Is it okay? Now, for this discussion, so by using double field revolving theory, okay, we got FA minus becoming like this, FB minus becoming like this, FC minus is getting like this. I just FA minus, okay, FC minus, whatever, FC minus, FB minus becoming like this, okay, this portion. So I wrote here Fr minus is equals to Fa minus plus Fb minus plus Fc minus, it's a vector sum as set 0. Now what about result forward components Fa plus Fb plus Fc plus, Fa plus Fb plus Fc plus, and Fr plus is equals to Fa plus Fb plus Fc plus. It's an arithmetic sum because they are in phase vectors. So I got value 3 by 2 Fm cos of theta minus omega t, and you told that resultant of backward is becoming absent, only resultant forward MF is existing, therefore motor rotates in forward direction. This is the conclusion you told, right? Now here let me have some important point, so which is very important for examination point of view. How can you change direction of induction motor? If you want to change the rotation of induction motor, what you have to do? This is very important. Okay, just let me write here. So this is important note here. Let me write direction of three-phase induction motor can be reversed by changing the phase sequence, is very important. And write in bracket, we have to change only phase sequence. We should not disturb your windings arrangement. Okay, by changing the phase sequence without disturbing windings space displacement, without disturbing winding space displacement angle. That is phase sequence changes means what? Instead of ABC, now we should take what? ACB. This is what IA, this is what IC, and this becomes EB. ACB is the phase sequence here. That means IA means what? What about this value? IM cos omega, which is reference for us. And here IB previously wrote cos of omega t minus 120. Now what of this one? Cos of omega t minus 240 or plus 120. IM cos of omega t plus 120. IC IM cos of previously wrote cos of omega t plus 120. Okay. Now it is minus 120. Cos of omega t minus 120. And whatever windings, you should not, I told you, without disturbing windings, winding space displacement angle. That means previously A phase number of turns means I just placed number of turns, N phase cos turns I just placed. Now also in B phase, N phase cos of theta minus 120, just like previously. C phase, N phase cos of theta minus 240. We should not disturb, windings displacement angle should not be disturbed here. And by using double field revolving theory, I already discussed in previously. Now I'm just writing. Previously Fa minus Fc minus Fg minus becoming like this. That means what? Resultant backward MMF becomes 0. Now Fa plus Fc plus, and here Fb plus, Fa plus, Fc plus, Fb plus. Okay, here Fr plus is equals to Fa plus Fb plus Fc plus. It's a vector sum which becomes 0. That is what? That is resultant forward MMF wave disappears. And what about these values? Fa minus Fb minus Fc minus, Fa minus Fb minus Fc minus, they are in phase. Therefore, I can write Fr minus is equals to Fa minus plus Fb minus plus Fc minus. So what of this sum? Arithmetic sum. This value becomes 3 by 2 Fm cos of theta plus omega t. Here it's a minus. Now it becomes theta plus omega t. So what about this Fr minus means what here? Fr minus means what? Resultant backward MMF wave exists. What's the meaning for that? Previously resultant backward becomes 0. Resultant forward is there, more rotation forward direction. Now resultant forward becomes disappear. What of this Fr minus resultant backward MMF exists? What is the meaning for that? That is motor rotates in, I can say, here I can write here. That is motor rotates in backward direction. It's very important. Please try to remember this note. Direction of three-phase induction motor can be reversed by changing the phase sequence. Instead of taking ABC, I had taken ACB. For ABC phase sequence, for this windings arrangement, so your resultant backward wave disappears here. Only resultant forward wave exists. Motor rotates in forward direction. Now if I take instead of ABC, if I take ACB phase sequence without disturbing physical displacement angle, okay, without disturbing physical displacement angle between windings, I'll get here resultant forward MMF disappears, whereas resultant backward MMF wave exists. That means motor rotates in a backward direction. So this note you have to remember. If you change phase sequence, so definitely direction of your rotating magnetic field will be reversed. Because of that, direction of rotation of a rotor will be reversed. Okay. So induction motor direction can be changed by changing phase sequence without disturbing a phase displacement angle between windings. Okay. Please note down.